What's up, everybody? So this is Ryan here, and in this video I'm going to be taking you along with some coding work that I plan to complete today. So I was going to live stream this, but I'll be honest, I'm really exhausted today, and I just don't think I'm really up to do live video. But what I'll be working on is basically writing out tests, applying test-driven development for use cases in my POS Trainer application. So I'll be working on that and basically just getting the tests running and implementing the complicated use cases, and then we'll see if I get into other things, but that's the main priority for today. So I'll probably still ramble a little bit as I'm coding, but this is basically just me taking you along with some actual coding work that I want to get done today. So that's basically it, and let's just jump in. So where we are starting out here is I basically just got started writing one test for one of the more complicated use cases in my application. So just for some preliminary information, one thing I came across recently is there's this run blocking test coroutine builder, which comes from the kotlinx.coroutines.test dependency. So do consider checking that out if you want to basically run your tests in coroutines scope, essentially. So basically having this here, a lot of these things are suspending functions that I'll be calling. So this just allows me to actually work with the coroutines and still actually get everything working properly. So another thing is the tool that I'm using to actually set up the mocks for my tests and verify the results. I'm using both JUnit 5, and then I'm also using this wonderful library called Mockk. Highly recommended. I've got quite a few tutorials on this particular tool, but not only does it basically make it very easy to set up mocks. So here what we're doing is we're creating the objects which the use case I'll be testing, which in this case is dismiss alarm, will talk to. So all we do is we create these mocks up here, super easy. And then when I want to basically, when the use case calls a particular function on one of the mocks, I can specify what to do, what to return in that particular case. So for this test here, the use case is going to be talking to this thing called alarm service, which basically manages alarms. And so for example, when we call dismiss alarm, then we return some particular response. In this case, I'm just returning a result wrapper that contains unit. So this is basically my way of saying I just want to know if this thing completed properly, but I don't actually want a particular value. If you're not familiar with unit from Kotlin, it's pretty similar to void. In fact, it generally maps to void in Java bytecode. So yeah, that's the basic gist. I've got this unit test working properly, so I'm just going to work on the other tests that I need to cover for this particular use case. Now, what I like to do when I'm writing these, when I'm applying test-driven development, is I'll actually write out my problem statements before I write the actual tests, and that just helps me to understand exactly what kind of tests I'll need. And in the problem statement, I'll specify different potential event streams or paths that the program's execution can take. And I'll usually denote these things using like A, B, C, and D, or however many letters or different potential paths exist. So for example, like the first thing we need to do when we want to dismiss an alarm is we need to tell the system service, and this happens just by talking to this service object. We basically just tell that thing, hey, stop all of these services. Now, of course, we'll be talking to a mock version of that. So we tell that thing to stop, and then we try to, and we assume that that's going to work. And then we try to retrieve the alarm which was stopped from the database. So if the alarm is retrieved successfully, and so here's basically where we start to get into different potential paths. So if the alarm is set to have this, let me just pull up the file so you know what I'm talking about here. So alarm is a data model. Sorry, I've got this over on the other side of the screen. Let me just fix that up. So the alarm object has this particular property called isRenewAutomatically. I could probably shorten that to just renew automatically, but whatever. And basically what this means is it's whether or not the user set a repeating alarm. So if the alarm is a repeating alarm, then we actually don't really need to do anything. I found out as I was actually writing out this unit test, because it'll actually be in the actual alarm service when it's initially created. That's when we tell it to repeat. So anyways, yeah. So if it is not a repeating alarm, then what we need to do is we basically need to pull that alarm from the database, set it to inactive. That's another field in here, whether it's active or not. So we set that to false if it's not a repeating alarm, and then we write that back to the database. So anyways, this problem statement up here was written a little bit before I actually got to work writing out this particular use case here. So anyways, it's a little incoherent. But trust me, I really do think it's a good idea to write out these problem statements, or even you can go from user stories. And you want to basically just get a general idea of what you're trying to test for whatever unit you're testing here, in this case a use case. And then you just go from there. So with that being said, I'm going to carry on. So we've got this one working, and that in just writing this one single test, I've covered most of the functionality of the unit, but of course we're going to write a couple extra tests. So I'm just going to copy and paste all of this crap here and put it down below there. And this is going to be case B. So in case B, we're working with renewed alarms. So we need to rewrite this particular problem statement here. So we're always going to tell the service to stop playing the alarm sounds and the notifications for that. And then we're always going to retrieve the alarm from the database to check its status. So what we're going to do in this case is we get check alarm status, renew automatically, and that's actually going to equal true. And write alarm to database with active will need to be true as well. And so we'll just need to make sure that our test down here reflects that accurately. So active in update alarm is going to need to be true. So what we're going to do, we need to make sure the test data accurately reflects the state that we're trying to test. So what I've set up is within the test folder of the domain module, which is what I'm actually testing here, I have a file, oh, that didn't work so well, called test data, and it basically just contains a function which is capable of creating an alarm object with what are known as default arguments, I believe, or default parameters or whatever. Just values which are defaults which we can override when we want to override them. So I see active, where was that? Is active is set to true automatically, so I don't even really need to mess with this thing. So we want to make sure we can get rid of that because that's already going to be the case. We can get rid of that. Now in the test data, renew automatically is set to false, so that's one thing we will need to change. So we're going to be saying get alarm by ID, by the alarm ID from the test data, and then we need to make sure that this says, what is it, is, what did I call it? Is renew automatically. Can I name it something else? There we go. I forgot to add the is in the default parameter there. So this needs to be set to true. And we need to make sure that that's reflected in the other test cases here. Okay. Renew automatically equals true. That should be the case. Active should still be the case. Now here's the thing that I totally forgot and just realized again. So if we pull the alarm from the database and it says renew automatically equals true, it should still say active because, how can I explain it? Whenever an alarm is set, it gets written to the database as being active. So technically, all I really need to check here is I just need to know if this particular property equals true. If it equals true, I don't actually need to rewrite it to the database. And the reason why is that the only thing that I would actually be updating in the database would be renew automatically equaling true. So I'm not actually updating it. And then it would also be is active equaling true because it's being reset. And it should already, what I'm getting at here, my brain's not working very well today, but what I'm getting at here is that I just need to check on whether it's renew automatically, and I don't actually need to call any update to the database if that's the case. So I'm just going to remove this particular test case, or mock response, and then this verification down here. So we are still going to tell the service to dismiss the alarm, and we still need to say to the repository, we still need to retrieve it just to make sure, but that should actually be it. So what I'm going to do is I'm going to write one more test case. I probably won't, what I'll do is I'll pause the recording while I'm actually compiling and running the tests because my computer's just not really, I could record at the same time, but the video will look choppy and it'll slow my tests down. So yeah, anyways, we're going to do one more test case here, which will be when the let me just make sure that's, yeah, alarm dismissed, renewed. Okay, that's correct. Alarm dismissed. So this would be a weird sort of edge case, but this is when alarm dismissed ID invalid. So this would be when the, you don't always want to test the path that works in your programs. You also have to test things that don't work when things go wrong, essentially. So here we're going to say tell the service to stop alarm sounds, retrieve alarm from database equals, and then we're going to, I think in this particular case, how I would like to do this. So I can either return a null or I could throw an error. I think we're going to throw an error. We're going to throw some kind of IO exception. We can say, what exceptions have I made so far? Yeah, we'll say alarm repository exception. This is just like a constants KT file. So this basically just has some data which represents specific exceptions, and it just makes it a little more legible. We're using a Kotlin object here, so we're using our memory more efficiently. So back to the test. So throw, I already forgot what that thing was called, alarm repository exception. And that's basically all we need to do. So to actually set this up in the test, in the result wrapper object, we're going to actually say throw. And that's going to be the alarm repository exception. And so we want to make sure that that gets called with the alarm ID. That's fine. And I think in this case what I want to do is I want to actually check the result which our use case produces. I'm not so concerned about that up here, but down here I am concerned to make sure that we're getting that result wrapper. So what I'm going to do in this case is we're going to actually say val dismiss, is that spelled correctly? I think it is. Dismiss result equals, and this use case here that we're actually testing, I'll show you what it looks like. I've already implemented a lot of it, just implementing my first unit test up here. So what it does is eventually it's going to return some kind of result wrapper object when I call this build use case function. And so in this case what I'm testing, I just want to make sure that we get our error, our sort of exception out of that result. It's kind of a pointless test, but I'm just trying to do some adequate code coverage here. So what we're going to actually verify is I want to say, let's see what options we have for JUnit 5. So if I recall correctly, so we're going to say, let's do assert true. Is that a thing? No? Okay. Maybe just assert. Yeah, it accepts a Boolean, so that should work. So we're going to say assert dismiss result is result wrapper dot error. So that's what we're trying to figure out here. And how this result wrapper works, you might also be wondering about that. Basically, I just call this build function whenever I want to create a result. If the result is successful, then the result wrapper's type, it's a sealed class, but the type will be success. If an exception is thrown, then it will be of type error, and it basically just wraps that error. So very handy little construct there. So what I'm going to do is I'm going to just run all these tests, and then we'll see what happens after that. Okay, so we have a triple green light, I guess, in simply implementing the first unit test case. I was able to cover all of the functionality for this particular unit, which is kind of handy. Doesn't always work that way, but in this particular case, that's how it did work. We'll be coding more use cases, so you'll actually get to see me write some implementation shortly. But what I wanted to do is I just wanted to make sure I had one set up before I got busy recording. So there's one more thing we're going to do in this particular case. So I basically want to just use Mockk to just double check that nothing funky is going on. So what I'm going to do is I'm actually just going to copy and paste something from a different project. This is Space Notes. And I'm just going to paste this function in here. Now, because this thing, that's a JUnit 4 annotation, I'm not actually using JUnit 4 in this module, so we're going to use a JUnit 5 version, which is after each. Fun confirm. So what we're doing here, we're basically making sure that pretty much we're So basically what we're doing here is we're just making sure that our different mocks have had verification calls on them, because if we're not verifying what they do, then we're kind of wasting our time to some degree anyways. So what we pass into this thing is our mock objects, which is service and repo. And then what we can do is, you'll use exclude records with confirm verified for calls which we don't especially care about. So that could be like in the other project, I was talking to a dispatcher and things like that. I don't think there's anything we actually need to exclude in this particular case. Let me just double check. Yeah, I think that's fine. That should do. So I'm just going to get rid of exclude records in this case. And then we will run this test suite one more time and see how it works. Okay, everything's still working, so that is fine, and we can move on to the next use case, and we will actually write the implementation for that. Okay, so we're going to find another use case to build using test-driven development. So we're not actually going to be applying test-driven development to every use case. So some of the use cases are literally like one-liners. So we're just saying like, oh, hey, alarm repository, delete this alarm. So if you need to support your one-liners with tests, well, I don't know, I should be careful what I say here, but this is to me, well, here's how I typically explain it. I get asked all the time, what should I test? Should I go for 100% code coverage? Should I, simply put, what should I test? Test logic, test complex code. In this case, we're basically just delegating a single call to a repository object. So this is not something where I really feel like I need to have it backed up by tests. Now, obviously, I need to make sure I look closely at it and make sure that I'm calling the right function. But yeah, this is not the kind of thing that we're going to write using test-driven development. Let me find another one which isn't implemented, and we can figure it out from there. So before I got to work basically rebuilding this application, what I did is I sat down and I figured out all the different use cases which you see here. This is a use case, so things that the app needs to do in order for it to solve its problem domain. So there's different terms for that process. Some people call it problem domain analysis, writing problem statements, and this is also very closely related to user stories if you're familiar with that. It's all about essentially analyzing the problem domain, and if you're wondering what the problem domain is, I wrote an article, I believe it's called something like Programming Fundamentals. I think it's the second or third article in that series where I talk about problem domain analysis. So it is very important for programmers to know that, but anyways, how you basically do it is once you figure out like the general high level thing that you want your, in this case, use case to achieve, then you want to write out a more detailed explanation of what it's going to do. So this is actually kind of where, in my opinion, test-driven development should start. It should start from like a verbal description of what you need to code. So what are we doing when we're canceling an alarm? Well, there's a couple things going on here. So it's not just that we tell the alarm service to cancel the alarm. Because if I were to do just that, then I would have an alarm in the database that says active, but it's actually canceled. And I want to fix that. So what we'll do is we'll just write out the different steps. So step number one, tell alarm service to cancel the alarm. So that's going to cancel the pending intent for the alarm. Two, we're going to say, so we're given an alarm as a parameter. So what we're going to do is, since we're given more than an ID, we're going to say write alarm to database with active equals false. And that, off the top of my head, I think that's all we need to do here. Cancel the alarm and then write it to the database with active equals false. And I don't think the other fields really matter. So instead of just jumping in here and writing out the implementation for this class, what I'm going to do next, I did stub these things out, and this is something I will do even if I'm applying test-driven development. Some people would argue that that's not a good idea, that you're supposed to actually write basically a test before you write any of this code. And in some cases I will do that, but when it comes to use cases, I kind of know a little bit better what I need. And I've already designed the contracts for the backend services a little bit. So again, people will make really extreme statements. You can never write any production code unless it's to make a unit test pass. I think that's a good principle, but you have to understand that everyone kind of has their own style, and there are cases where I think following the rote procedure a little bit too closely can slow you down a little bit. So anyways, I'm not saying Uncle Bob is wrong about test-driven development, but this is just the way I like to do it. So we're going to right-click on, let me show you what I'm doing here. So I'm in the test package for the domain layer, and we want to create a new unit test class for cancel alarm. So we're going to right-click on there, go to new Kotlin file or class, and we're going to say cancel alarm test. Now, since I already have a test case created somewhere here, what I'm going to do is I'm actually just going to copy and paste the other one over there, so I'm not starting from scratch. You know what, maybe I will start from scratch, because I guess people are probably wanting me to do that. So, you know what, forget about that. We'll go to cancel alarm test, and I will just try and code this thing out all by myself. Class cancel alarm test. So the first thing we want to do is we want to create the mock objects that we'll need. So in this case, we're going to need val service, which is going to be of type, what the hell, autocomplete? Why did it give me the option and then not actually autocomplete? That's bizarre. Okay, whatever, I'll just do it by hand. So what is this thing called? Alarm service? Yeah. So for anyone wondering, like, this is one of the main reasons why you apply the principle of code to an interface. It allows you to build and verify classes independently of each other, because you're depending on an abstraction versus the real thing. So just a little pro tip there. So then we just say mock, like that. I think that's correct. Let me just double check. That is correct. Let's just clean this up a little. I don't think I need those. I'll need cancel alarm, dismiss alarm. That should be good. Then we also need the repository. So we're going to say repo. Is autocomplete going to work this time? Not at all. That's depressing. Oh, there we go. Oh, it actually completed. Cool. I feel so lucky. Okay, so what we do is we create the mock objects. That's usually the second thing I'll do. And then we need to create the actual thing that we're testing. So what we're going to do here is we're going to say val cancel. Let's just call it cancel. Cancel alarm. Actually, what we can do is we can just say equals cancel alarm. That's a little more concise. And this thing needs to be given both a service and a repository object. And I could jump in and fix that now, but I'm going to wait until I have a test case running so that I demonstrate the proper TDD. Because I'm sure some people were offended by my earlier remarks. Okay, so that's the first thing. Now we need to set up like a before test case. So when we're working with Mockk, before each test I want to call this clear all mocks function. And that basically clears all the prepared mock responses and makes sure we don't have any weird behavior in that way. So we're going to use before each, which is again JUnit 5. And then I think I called this fun setup. What did I call it in? Fun build, okay. Whatever, that'll do. Fun build. And then we're just going to say clear all mocks. Okay, and then we're going to move into writing our first test case. So I'm going to say at test and fun. So I'm going to use the backtick character, these two backticks, and that's going to allow me to create a function name which is in like written plain English. And so let's look at my problem statement here. So tell alarm service to cancel the alarm. I'm just going to actually start by writing out this problem statement here. So 1, let's just copy it over, actually. That's a little easier. Okay, so tell alarm service to cancel the alarm. Write alarm to database with active equals false. So the only other test I'm going to run here is when we get an error. But yeah, for here we're just going to say on alarm canceled. And we'll of course need to use, this is going to be calling suspending function, so we'll have to use that test thingy. What was that? Run blocking test, was that it? Yes. Okay. And then we can get to work. So the first thing we want to do is set up our mock responses. So we're going to say what is it? No, that's not what we want. I can't remember what it is. See, this is how my brain works when I'm tired. I just can't remember like verbal written information because I'm very much a visual thinker. Every. See, I've written this function out every like literally probably 1,000 times, and when my brain is tired, I can't even remember how to write that. Luckily, my problem-solving faculties still usually work okay. Okay, so every, and then we have returns that's lowercase. Okay, so when, this is essentially like when every time blah happens, return blah. So the thing we're going to call is we're going to be saying to the alarm service, what did I call it? Just service? Yeah. Dot cancel alarm with, we'll just say get alarm, so that's coming from our test class again. And what is active set to? Active is true. Okay, that's fine. So when that happens, we're going to say result wrapper.build, and we're just going to return unit. So if you remember, like I said before, this is just my way of saying, okay, it happened successfully, but we don't care about what the actual result is. This is very much like a completable if you're familiar with RxJava, or maybe like if you're not, maybe like an async task that returns void. And then we need our repository. So we're going to say repo.update alarm. And what we need to do is we need to make sure that active has been set to false because it's been canceled. It is no longer active. And I think this also returns a unit. Let me just show you the interfaces so you're a little less in the dark about what I'm doing here. So for the different things that are going on here, so when I'm deleting an alarm or updating an alarm, I don't actually need to return a specific object. So this is where this unit thing comes in. So if there's a problem, we return an exception. Otherwise, we return a unit. If I actually need to return something in that particular function, then of course we will return whatever I need as the generic type there. And we'll have a quick look at alarm service. Similar idea here. I never need to return a value from the alarm service because we're just talking to a system service. So I just, again, want to know, did it succeed or did it fail? So we're calling update alarm, returns unit, that's fine. We'll need to call the actual use case. So what we're doing here is we're saying cancel dot build. What are we saying here? Execute. That's the public function. Cancel dot execute. That actually comes from the base class. By the way, for those curious, I'm using, let me pull up use case with params. The use case base class that I'm using is from my friend Darrell Bitsy's Clean Arch repository. You can check it out. GitHub Bitsy Darrell Clean Arch. And what this thing does is it just contains a whole bunch of handy Kotlin. It's like a library which contains a bunch of stuff which you can use to architect a clean architecture application. So I did make some minor edits to it. I just added suspended functions. I know Darrell doesn't necessarily like to tightly couple his use cases with coroutines, so that's one thing I'm quite happy to tightly couple my use cases to coroutines. But yeah, the majority of this code is from his project there, so I just wanted to give a quick shout out. So back to our test case. So we're going to call execute, and this thing requires an alarm. And so we're going to say get alarm, of course. And then we need to write our verification. So when you're, again, if you're not familiar with Mockk, if you're not working in a suspending function or a coroutine scope, you can just call verify, but in this case we need to use the co-verify. And so what are we verifying here? So I just want to make sure service.cancelAlarm was called with get alarm is fine. We're basically making sure that we're making sure that this and this were called with specific values. So we make sure that service.cancelAlarm was called there. I'm going to hit Control D, and this will be repo.updateAlarm. And then active needs to be equal to false. And that's basically it. So I think we're good to go here. I'm just going to pause and run the test, and we'll see. It will fail because I haven't implemented it, and we'll just kind of go from there. Okay, so I was not able to actually run the test because we have a compilation error. So this is the actual test-driven development process. So now I have a test case that is failing, and I am allowed to now go into the class that I'm testing and fix it to get that test to pass. So of course the reason it's complaining is that there's only one property here, which is just the alarm service. So I'm going to go ahead and add in private val alarm repository. Why is that not showing up? Oh, that's kind of silly. There we go. Repo alarm repository, like that. This thing needs to be called service. Didn't even notice that before. Okay, so we're going to try and run the test again, and that should fix the compilation error. And I'm an idiot because I ran the wrong test case. Okay, I think we can get rid of dismiss alarm test now. That was kind of silly. Okay, so we want to be running this one here, cancel alarm test. And unsurprisingly, it is failing. So let's just have a quick look at why it's failing. So it's basically saying verification failed, ialarm repository.updateAlarm was not called. Now we have another failing test, and we can go back in and implement that. So we're going to go to cancel alarm, and we need to, so for starters, I'm going to remove this thing from being, I'm going to change it to a non-single expression syntax. And so what we're going to do is we're going to say val cancel result equals service.cancelAlarm. And we're going to do our good old when matcher. Or let's do an if statement here because I only have the two cases. So if cancel, oh, I did not spell that properly. If cancel result is result wrapper dot success, then in that case we're going to say return repo dot update alarm, and alarm is params, but we're going to say params dot copy. So copy is a function from the data keyword. If you've ever wondered about data classes in Kotlin, this is one of the things that they add. So this is going to copy all of the different property values, but one of the handy things about copy is that we can actually use default arguments again to change only the things that we want to change. So what I'm going to do is I'm going to type is active, I think, yeah, and then we're going to set that to false. So that's going to create a copy except for that particular thing, and we're just going to return that result. So otherwise, so if cancel result was not successful, we're just going to return. I can actually let's just clean this up a little bit. We can do some nicer syntax here since it's just single line expressions. Yeah, so I'll zoom in so that you can see what I'm doing here. So we can even lift that return statement out there. And then we can say else. So if this thing is not successful, it's going to be wrapping an error. So in that case, we can actually just return cancel result. So I'm just going to say cancel result. And everything should be working fantastically at that point. So let's hop back. Actually, I'll just run the test case up here and we'll see how we do. Boom. And we have a passing test. So the next thing I'll do is I could probably write an error case, but at this point it's almost kind of pointless. If for some reason the cancel alarm fails, there's just not really anything I can do about that in the back end other than not updating the alarm. But even then, you know, I could if that case fails, I could also call update alarm and set it to inactive, but I'm not actually guaranteed that the alarm is inactive, so I'd actually rather just kind of do nothing in that error case. So I'm not even really going to write a test for that because, again, this is a very simple test case, and it's not really... I can just tell by looking at this, I've written this style of code enough that I don't actually need to really bother with... I don't need to support this particular error case with the test. So we're actually going to call that done, and I think what I'm going to do is I'm going to finish off the rest of these use cases off camera, but hopefully taking you along for that was somewhat interesting. When I get to some more complicated stuff like the logic classes, then I will hopefully be able to take you along with that test-driven development process as well. Use cases are generally pretty easy to write out. They're supposed to be as succinct as possible. So hopefully that was interesting. If it was, do me a favor, hit the like button down below, and I'll see you in another live coding episode that's not actually live because I am tired as f*** today. So thank you for watching and peace out.